In 1865, Joseph Bazalgette began building 3 separate pieces of infrastructure simultaneously in the same trench beside the River Thames. The first was a sewer, a low-level interceptor tunnel running below the north bank, built from 31 million bricks, designed to carry the waste of a city that did not yet fully exist. The second was a railway, a cut-and-cover underground line enclosed in a brick tunnel running directly above the sewer. The third was a road, the Victoria Embankment itself, new thoroughfare constructed on land reclaimed from the river, running 1¼ miles from Westminster to Blackfriars, along what had been open water. 1 engineer, 1 excavation, 3 permanent structures, all completed by 1870, all still in daily operation today, 159 years later, carrying precisely the loads Bazalgette designed them for and loads he never could have imagined. While watching this video, which was made with great effort and research, be sure to click the subscribe button you see below, because if you do, you'll be introduced to the great construction projects of the Victorian era. As a big action for us, but a small one for you, you can subscribe to the channel, like the video, and specify in the comments which period structure you want us to examine next. Joseph Bazalgette was appointed chief engineer of the Metropolitan Board of Works in 1856. He inherited a city in crisis. London's population had reached 2.5 million. The Thames was an open sewer. Every tributary crossing, the City, the Fleet, the Effra, the Walbrook, discharged raw sewage directly into the river. In summer, the smell from the water forced Parliament to hang chloride-soaked sacking across the windows of the Palace of Westminster. The summer of 1858 became known as the Great Stink. The cholera outbreaks that followed contaminated water had killed thousands in 1832, 1848, and 1854. The connection between contaminated drinking water and disease was only beginning to be accepted. Bazalgette accepted it and designed accordingly. His response was the largest civil engineering project London had ever attempted. 83 miles of main sewers running north and south of the Thames, feeding into low-level interceptor tunnels that carried flow eastward to pumping stations at Crossness and Abbey Mills. 318 million bricks in total across the system. The mortar was hydraulic lime, capable of setting in the presence of groundwater. The egg-shaped brick tunnel profiles were calculated to maintain self-cleansing flow velocities across a wide range of discharge volumes. Every dimension was derived from calculation. Every material was specified precisely. The low-level northern interceptor presented a specific problem. It had to run close to the Thames, low enough to collect by gravity from the city's existing street drainage. But the ground between the Strand and the river was already fully occupied. Buildings ran to the water's edge, inserting a sewer of the required dimensions without demolishing large areas of central London was not possible within the existing footprint. Bazalgette's solution was to create space by moving the riverbank. He would build a retaining wall of mass concrete along the foreshore, reclaim the ground behind it, and bury within that new ground not 1 structure but 3, the sewer at the base, the railway above it, and the road surface above both. The Victoria Embankment reclaimed 37 acres of Thames foreshore between Westminster Bridge and Blackfriars Bridge. The retaining wall on the riverside was built from mass concrete and faced with granite blocks designed to resist the full hydraulic pressure of a tidal river whose range at London Bridge exceeds 20 feet. The wall dimensions exceeded the minimum structural requirement. When the Board of Works questioned the excess, Bazalgette gave an answer that has been recorded and repeated ever since. If he calculated the exact minimum and made any error in execution, the wall would fail. Built to double the specification, any error in execution would still produce a wall that worked. The granite-faced mass concrete retaining wall along the embankment has not been reconstructed in 159 years. The construction sequence below the new road ran from the bottom upward. First, the low-level sewer, a brick egg-shaped tunnel 9 feet at its widest, its invert set 30 feet below the eventual road surface. The brickwork was laid 3 rings thick in hydraulic lime mortar in standing groundwater, working by candlelight in excavated trenches cut through the Thames foreshore. Above the sewer crown, separated by a layer of mass concrete, came the District Railway, a cut-and-cover tunnel with brick walls 18-inch thick, its trackbed set into the tunnel floor. Above the railway, running in the space between the tunnel crown and the road surface, Bazalgette laid service conduits, gas mains, water mains, and hollow ducts for telegraph, cables, infrastructure, anticipating communications technology that did not yet exist. At the surface, the carriageway, 60 feet wide, gas-lit, planted with plane trees along the river wall, opening in 1870 as the finest urban thoroughfare in Europe. The workforce at peak construction numbered approximately 800 men on the embankment section alone, with thousands more working simultaneously on the wider sewer network across North and South London. They worked in open cofferdams cut through the Thames foreshore, continuously fighting tidal groundwater ingress. The river at this stretch is fully tidal, its level rising and falling by more than 20 feet between low and high water. The timber and iron cofferdams that held the river back during embankment wall construction had to be maintained through every tidal cycle, pumped continuously, and rebuilt when storm tides overtopped them. In the winters of 1866 and 1867, construction reports describe men working in water to their knees for days at a time. Bricklayers working the sewer invert section worked by candlelight in tunnels too low to stand upright, in groundwater that the pumps could not fully control. The hydraulic lime mortar they were laying required dryness to cure correctly. They laid it anyway, and specified a mix that would tolerate moisture in the joints. Most of it cured. The tunnels it produced are still watertight after 159 years. The Metropolitan Board of Works recorded progress in yards of tunnel completed per week and tonnage of concrete placed per month. It did not record the names of the men who completed them. The material specifications throughout the embankment project were written to exclude compromise. The granite blocks facing the river retaining wall were sourced from Cornish quarries and specified to a minimum density and minimum compressive strength that ruled out the cheaper local alternatives. The brickwork for both the sewer and the railway tunnel was specified in engineering brick, harder, denser, and less porous than the common stock brick that would have met the minimum load requirements. The hydraulic lime mortar was sourced from a supplier whose product Bazalgette had tested and approved for underwater use. Every deviation from specification on site required his personal written authorization. Several contractors found this inconvenient. The structures they built have not required reconstruction. The district railway section opened in 1870. It has operated continuously since, expanding into what became the district line, carrying tens of thousands of passengers daily through the same brick-lined tunnel Bazalgette's contractors built. The tunnel has been maintained and its equipment upgraded repeatedly over 159 years. Signaling systems, lighting, the track and its bearings, all replaced multiple times. The brick structure itself, the
walls, the invert, the arched roof that supports the road surface above, is original. Transport for London's structural engineers inspected on a cycle that has not yet produced a recommendation for reconstruction. It supports the weight of the embankment road, the weight of the trains below, and the weight of every vehicle that has crossed the road surface since 1870, including the heaviest lorries and buses of the modern era, none of which Bazalgette encountered in his calculations. His calculations accommodated them anyway, because the margins he built into the brick tunnel walls were sufficient to absorb loads he could not have specified.
The low-level sewer still carries London's sewage eastward by gravity, as Bazalgette designed it to do. He calculated capacity for a population of 4 million, double London's population in 1865. London's population today exceeds 9 million. The tunnels have handled the increase without the fundamental reconstruction that a structure designed to the minimum required standard would have necessitated decades ago. This was not fortunate over-specification. Bazalgette stated his method explicitly when challenged on the capacity figures during the design review. He took the most optimistic foreseeable population figure for London's growth, doubled it, and used that doubled figure as his design load. The board questioned the excess. He held firm. The doubling has kept the system functional without core reconstruction for 159 years. The pumping stations that lift the flow at the eastern end of the system have been upgraded. The tunnel that carries the flow has not been touched. A sewer designed in 1856 for 4 million people is serving 9 million without structural complaint. That is what correct specification at sufficient scale produces. Not a structure that needs rebuilding within a generation, but one that outlasts the engineers who questioned it. Walk along the Victoria Embankment today, and you walk on ground that did not exist when Bazalgette began his survey. 37 acres of Thames riverbed, reclaimed from the water, held against the tidal river by a mass concrete wall whose core has not been rebuilt since 1870. The plane trees planted at the opening are still there, their roots above the district line tunnel. Below the road surface, 2 meters down, run gas and water mains in conduits, Bazalgette installed. 4 meters down, district line trains run through his brick tunnel. 12 meters down, the low-level sewer carries precisely the function it was built to carry. 3 structures, 1 trench, 1 decision, still working. A project of this kind today would require separate planning consents for each infrastructure element, separate procurement processes, separate contractors, separate construction programs running in sequence rather than simultaneously. The coordination overhead alone would extend the project timeline by a decade. The cost, adjusted for modern civil engineering economics, would be measured in tens of billions of pounds. Each element would be specified to its minimum required standard, optimized for the construction timeline rather than for the service life to follow. Built to last 40 years and then assessed, Bazalgette built all 3 at once because building them simultaneously in the same excavation was the rational response to the disruption the work required. The sewer is still carrying sewage. The railway is still carrying passengers. The road is still carrying traffic. Here again you see a mega structure born from the intelligence of a talented engineer. If you would like more videos like this, please like the video and subscribe to the channel.